The reddish appearance of the sun at sunrise and sunset is due to. Okay. So here many points are there. Here there is scattering of the light, polarization of the light, color of the sun and the color of the sky. What is the exact answer here? Okay. So whenever the sun rays is falls on the earth, we have the long wavelengths lights are there, short wavelengths lights are there, and many in between the sun and the earth we have many particles are there like air, water, many water particles are there. When it falls, that the light falls in the water droplets or air, then it is get scattered, it is disturbances. This is what we call as a scattering of this light. Okay, see this rise is falls on this droplet, it is get scattered. Cool. Then we have the many points, we'll discuss that one also. The reddish appearance of the sunrise and the sunset is due to scattering of the light by the molecules of air and other fine particles present in the atmosphere. Okay. Then, at the sunrise and sunset, the sun remains below the horizon. Hence, light from the sun passes through the thicker layer of air and larger dense distances in the Earth's atmosphere before reaching our eyes. Okay. Then, the particles in the atmosphere scatters the majority of the blue light rays and some other specific wavelength of radiation. As a result, the only red light of the greater wavelength penetrates individuals, giving the sun as a reddish look at sunrise and or sunset. Very, very important point here. Okay. Therefore, the only red light being a higher wavelength reaches us, which gives the reddish appearance of the sun at a sunrise or sunset. So, this is major because of the scattering of the light. So, I can choose the option here. Option A is our right answer.